sure about participation of few more registrants, so I thought, okay, let's start now. People may be slowly joining. Yeah, before I proceed, do you have any special question here? In the registration form itself, whatever you have given the list of requirements as a special text box given, I captured all of them, and probably I should be justifying all of them. Even maybe few participants may not be here, but I have taken their requirement, and I will be addressing, by end of our session, I will be addressing most of the requirements. Okay, so we'll be proceeding like this. Maybe after half an hour and all, we'll be breaking for tea. Then we'll be around 1:30, we'll be breaking for lunch. Then depending on how our dialogues go, it's up to the participants. If you want to stay back for some more time and discuss something on that, we can as well proceed after lunch. Otherwise, we are done with lunch. Okay? Thank you. So as the title of this session, mainly intended for the academicians who are interested to pursue some kind of research activity, which could be as a part of their PhD program, as a part of their UGC or DST sponsored or some other category project, or maybe just an interest apart from their regular curriculum subject teaching activity, aligned to the same subject teaching, they wanted to pursue some research. So this particular seminar is intended to give an outline, motivation, broad guidelines, the fields. This particular seminar is likely to actually carry forward in a specialized sessions where we call the people of a certain field of interest, maybe VLSI, power techniques, maybe signal processing, all different sessions. So this I can call it, I can look it as a starting point. From here, different specialized seminars we will start. So a little bit of background, like why we are doing this activity and what is our intentions are. You know very well that Unistring Tech Solutions, right from its beginning, from 2005, under the academic training division called String Technologies, was doing a lot of workshops, seminars and all. And in year 2006, 7 and 8, String Technologies has done under UTS VLSA Forum, plenty of VLSA workshops, seminars, free training programs to academicians. So under our academic training division, String Technologies, we always keep only one category of the events free. That is, whenever we get an opportunity to train trainers, that is teachers or professors, assistant professors, that we would like to do as many as free events possible, so that they are not constrained by some college sponsorship or something like that. In fact, we would conduct most of such events on Sunday to see that they don't have any problems in getting permissions also from colleges. But this event somehow my team has felt Saturday is convenient, we did it. Okay. So the motivation of conducting this series of seminars is clear, and we want to do it in more aggressively now, do it at a higher level. So far we were doing events related to your curriculum, what you have to teach to your students and all. But now probably the time has come where the industry is seeing that the curriculum subjects are not suitable to a level that where they can start working in a company. And time has come where a lot of young academicians are in the track of pursuing PhD or doing some research project and all. The time has come where government is looking for a lot of initiatives from academicians, and they are ready to do a lot of fundings through different bodies and all. So now this is the correct time. What we felt, let's look beyond our curriculum and start offering something, whatever we can, to our fellow academicians, what we call as assistant professors, lecturers, professors of colleges. Okay, and few events we keep it exclusively reserved for the this academician, so that you, without any shy, you can reveal your ignorance, or you can openly ask your questions and all. We will not be calling any industry persons, we will not be calling any students for this kind of events. Okay, so let me proceed. So the agenda of this particular seminar is that first, that it will be a kind of overview talk. I feel it will be able to broaden your thinking about searching a research problem. The first session is about selecting a research area and topic. So right from the dark, you don't have any guidance from anyone. Okay, just you are across the computer and you need to find out a research topic. So keeping that basic intention in mind, very broad guidelines, not being biased to something. Somebody said low power is very good, somebody said some high performance very good, not being biased to that. If you want to pursue a research problem, where to begin with? See, our motivation is also that you people take up problems which are associated to closely our society. directly or indirectly, if they are addressing our society problems, that is, in a large sense, end to end, the motivation of pursuing research is actually fulfilled. Okay, so we will be talking about that. The second session talks about signal processing and image processing aspects. In fact, I haven't actually compiled a specific set of slides. I have different category of slides, so I will be flashing one by one. So, because signal processing, image processing are considered to be heart of the research when it comes to electronics and communications. So, what are all possible areas? What you might have heard about, you might have seen in papers, what you might have not seen, which are lying as industry problems, I will be presenting them. Then, I will be talking about UTS as a company, because it has got IP, intellectual property, and some products portfolio. We do have a lot of state-of-the-art hardware platforms like high-end FPGA boards, high-end graphic processing cards, high-end embedded processors like Intel Atom processors and other processing cards. Some of them we are actually open to share with our academicians over a short period of time, so that they can actually use it for their research demonstration somewhere, or maybe they themselves want to work online, or directly carrying them for a day or two. So we are okay with all those models. So that's what also I will be talking about. Then we will be talking, so it's mostly because this is like an open topic, unlike a specific subject topic. Unless I address your needs, okay, the main purpose of this seminar is not getting fulfilled. So at some point of time I will take your feedback. During tea session or lunch session you can share your personal feedback also. So I will be fine tuning my session. Okay, I have plenty of presentations, so I can talk about all the electronics, communication and technologies and all. Maybe depending on your feedback, I will drop one PPT which I planned, I will open up the new one. Okay. Now, so I did some survey already through your online form. At the same time, maybe if you want to tell something now also you can do it. Now, I wanted to know how many of you are actually doing some research work already. Maybe it is a research work which is sponsored by a government or a private body, which is a DST project or a UGC project or some other project, or maybe a PhD problem which you are working on your own. I mean, both are equally good in the sense that you are doing a research. Okay, how many of you are doing? Okay, then it's good that I am addressing fresh talent, so you don't have any bias. So I have a chance to actually put you in the proper direction where our society problems can be directly addressed through academic research. How many of you did at least one conference or a journal publication? Few of you. Okay. I mean, but at least I say one paper, probably all of you might have done, because at least for motivating your postgraduate students, you would involve in a couple of paper publication. At some point of time, I will be talking about few tips and tricks how to evolve basically a good paper. It's not just a shortcut what we're trying to say. I'm trying to look in the point of whomever at the reviewers of your paper. What are the key quality-wise aspects they look into your paper? We'll be talking about that. Okay. Then how many of you did some decent big simulations in Octave or MATLAB or some other kind of platform? Few of you. Okay, good. I mean, yeah, already your requirements are there in my separate sheet. I'll address them. Okay, this is always my favorite quote, and I would like to share wherever I go. When I get an opportunity to talk to academicians and students, I will discuss on this. This gentleman, Albert Einstein, you know very well. He is he has done a lot of wonderful inventions in physics, and maybe apart from that, his philosophy is also very excellent. You will find that at the URL there is a URL given where that is written. In terms of understanding a certain subject aspect, okay, in terms of understanding a certain subject aspect or a concept, this point is really important. You do not really understand something unless you can explain it to your grandmother. Look, something very funny and very gross level, very basic level. What does actually mean? Mainly this is important for research. Why I am talking here, it's an important attitude one needs to have to pursue research career. Okay, if you want to do a research, you must clearly understand the meaning of this, and you should not come out of practicing this one. You should always practice in your research activity this statement. What actually it means? Most of the times we think research is fundamentally very hi-fi, very complex. It should have a lot of big equations, sigma, this, that, integrations and all. If finally that comes out of my research paper, that is going to be kind of innovation or very hi-fi thing. No. The most important thing here is research all the time runs around the fundamental concepts and fundamental principles. as much as you are clear in the fundamental concepts and principles, you will be able to contribute to the research also in that much high level. Okay, if your concepts are not clear, if your fundamentals are not clear wherever you are doing the research problem solving, you will end up with maybe publications, journals, you will put lot of equations there, you may get PhD, you may get the UGC project granted and you get the final, you hold something, but finally that will not contribute to anything because you yourself are not clear what problem you are solving. So fundamental concepts, basic level of understanding, what does it mean? You know what this gentleman says, that unless you can explain it to your grandmother, what does it mean? You must be able to speak in a very simpler qualitative statements to explain about any concept. Maybe I think I should take an example here to illustrate more about what I exactly trying to point out here. Let's take about correlation, okay, or some Fourier transform, or some wavelet transform. All these are look to be very hi-fi kind of through equations, right? All of you, if I give the paper and you will start writing about the equation, this is Fourier transform, this is a wavelet transform, and this is what is called something like maybe autocorrelation function, cross-correlation function law. But if you got to explain about the Fourier transform, okay, what will you do? Let's say your grandmother is sitting beside you, you have to explain Fourier transform to her. How will you explain? Grandmother, this is sigma and this is n is equal to this one. What is sigma? What is n? Nothing. You have to go one more level down, one more level down. If you can go to that bottommost level where you can qualitatively, practically explain, it means you understood that concept very well. This is the most important attitude a researcher needs to have. Okay? Please come out of the thinking that a researcher is something who does complex math and who actually comes out with a huge equations and all. Equations and math are definitely required to formulate what you are trying to innovate. Okay, in a kind of fashion which can be used by a computer-based tool like a MATLAB or some other modeling environment, definitely equations are required. Equations are the place where an engineering subject like electronics and communication, mathematical techniques like Fourier transform, jet transform, whatever vector calculus, to bridge both these two, you need equations. Okay, but equations cannot be a starting point, or equations cannot be the key point in research, because research fundamentally looks and works around the engineering problem. Okay, now let's say, I will actually approach like this. If I have to explain my grandmother about what is a Fourier transform, equation wise, yes, she don't understand, but I look at like this. A Fourier transform, what it does, let's say you have something like this, a signal. Okay, whatever coming out of my microphone, if it, my mouth signal energy, if you put it onto time scale, I have a signal like this, that much you can understand. Okay, now next, in this signal, there are so many frequency components. Okay, what frequency component, let's say a 10 Hz component, how much is the power in it or energy in it, I want to measure. Then what I will do, I will take infinite length, infinite in practical terms, over a long period of time. Over a long period of time, I will take a sine wave, which is actually exactly 10 Hz, multiply this with that, okay, then sum total, then I get a number, right? That number tells, okay, over the entire period of time, the energy of whatever 10 Hz component is this. Now see, that is what exactly the concept behind the equation in Fourier transform. Okay, I mean, my explanation is incomplete. I was talking about a Fourier transform, they are taking sine, but you have to take a complex that is cos and sine. It's okay. In this direction, if you start analyzing, approaching every equation, you never find difficult to read any transactions paper. You don't find frame paper also which goes to IEEE transaction level. You should be good in both the directions. Understanding an equation in qualitative terms, that is the first step. Okay, writing an equation out of what you understood is the second step. That is tougher. Okay, if I go back to your, what's called engineering education, people talk about few skills which you have to train, which you have to see that your students get develop these skills. Mainly there are two types of skills. One is called analysis skills. Second one is called synthesis skills. So what I am telling, the first one, which in the research you have to understand, you have to get full analysis skills. Analysis means you are reading an IEEE paper, there is a mathematical equation which is talking about applying some stochastic so technique along with what you know in a wavelet transform, a new equation which you are seeing. Unless you are habituated to understand all equations conceptually, you cannot understand this equation. If you cannot understand this equation, you cannot understand the existing work. You got it? When you want to take up a research problem, it is very important that your literature survey and your current understanding on whatever the work in the direction must be very solid and very clear. That is only possible if your analysis skills are very good. Maybe we can run through a separate seminar. At some point of time we will organize how to understand all equations conceptually in the entire electronics and communication engineering. Maybe it's a good topic. I'll ask my organizers to conduct that one. Okay, it's a completely open topic. You randomly take up any equation in any electronics communication book, could be communication, signal processing, how to interpret them qualitatively. Because qualitative interpretation only can tell you the underlying concept in that. Okay, so that's the most important. I think I have done what I'm trying to explain through this slide, that your research starts at a point, whatever could be the problem which you are trying to identify, whatever literature survey you are trying to do it, you have to pin down, understand every equation qualitatively, conceptually. That's the bottom line which I'm trying to explain. If you don't do that, if you don't do it, if you're trying to skip, okay, this equation I don't understand, this conclusion I don't understand, but still you complete your literature survey, definitely your research may complete as an administrative wise, but it won't give any, output by which you don't carry satisfaction over a long period of time. Okay, see all the, maybe I can further talk once I proceed to the further slides. Yeah, something like, what I'm trying to say, when you find all together I'm talking not relevant to whatever you are finding here, please stop me. And when you are actually finding that something I'm explaining also here wrong, you can stop me. Okay, I'm also not very strong in all the subjects, but for the sake of completion of topic, I have to address all the topics. Okay, so I'm talking about that. And whenever you find sleepy also, please let me know. Okay. So now I'm at the first session now. I'm now trying to explain about what are the broad areas. If somebody right at the beginning you are trying to look at a PhD problem, or you want to write a DST project proposal with some nominal funding where you are easily likely to get sanctioned, or maybe some AICTE, some sponsorship program, or you want to send proposals to few reputed private companies which are likely to actually have benefited by your research. All this you can do. Or you want to send a proposal to DRDO or ISRO kind of this. So not being biased to any technology, I am trying to illustrate all possible areas here. Now, why we are so particular? Our company has string technology ethically. Why more interested to actually encourage the academicians into research? Why academic research is very important. Academic research is a key to any national technological growth. Please remember that any key technology which is developed by a country is, it's very difficult that actually other countries can copy that or can easily get it. It's because it indirectly helps, what is it called, growing the wealth of that nation. It is very important that they preserve it, and that happens with in different motivation if it comes to a defense or a space sector. Okay, so any key technology that is developed by academic researchers in that country indirectly actually helps for the nation's growth. Couple of examples if you want to actually look at. Now if you look into this a company ARM, Advanced Risk Mission, which is actually out of an academic research. Okay, from I forgot, it's a University of Cambridge or some universities there. It's initial ideas, initial thoughts came out of that is actually ARM company today. And if you know today, ARM is the number one, and that is the architecture which is made by all the silicon companies, Intel. So what I'm trying to say, any key innovation done by academic researchers are going to change the face of nation's technological and economical growth. So it's important that country all the time encourages the academicians to do some research activity. Unlike the R&D wings in a corporate, academic research is not being biased by the product portfolio. Let's say a company is there. In a company, a scientist wants to actually take a grant on a research project. The manager will ask, what is my product portfolio out of it? Am I going to make money out of it in the next 1 year or not? If not, maybe your research topic may not be acceptable. Unlike that, academic research is highly encouraged and motivated to look at society-oriented problems. Okay, problems who may not have any profit inclination or a profit orientation. Okay, problems who are localized to your region or your segment or a community. All they are addressed by only academic researchers. Okay. Now, need to focus on problems faced by society and engineering sector, local engineering sector. What I mean is, the decades of preliminary research on machine learning and artificial intelligence opens ocean of directions for research. Now, maybe why do I think that there are, especially the Indian academic researchers, you got plenty of society-based problems to solve. I'll tell you. See, you know very well, like the engineering is taking different phases over last 2 centuries. Okay, in the 19th century, okay, are the early days of 20th century, 21st century. The inventions like a bulb, the inventions like passing current through electricity were itself taken as a very big inventions and all. And you have seen that what kind of phases our industrial research is actually going through. In the 1950s and 60s, when companies invented something called like computers. Okay, universities came out with architectures like a microcontroller, microprocessor, RISC, CISC and all. They became inventions and all. What you see is, if you notice what is happening in the last 2 decades, or what is very active in the last decade is, you are able to make a computer. Computer is a kind of silicon piece which understands maybe 1000 or 2000, or maybe if it is a big thing, 10,000 instructions. Whatever you want to tell, you tell in the form of instructions it does. That's a computer is. Now people are looking beyond that. Called machine intelligence, machine learning, artificial intelligence, neural networks. These are all genetic algorithms. These are all subjects. As a human individual, a biological entity, natural given power actually of giving thought, okay, reasoning, applying a logic which cannot come through a simple mathematical equation. Okay, people are trying to bridge what happened so far in engineering, probability. Okay, probability is a kind of subject which comes in the first when it comes to machine learning or artificial intelligence, because all the time human takes actually decision based upon the probabilities and all. Got it? When I show you some object, what's this? Your probability runs in the background, and okay, this is the maximum probability. Okay, you will declare that. So people are looking at applying what you learned in mathematics on top of these computer machines, so that some intelligence can be done in machines. Now, how it will help society and how it can help Indian society? No. Now look at, there are plenty of problems where since because our society is big in terms of number, in terms of area, in terms of diversity, okay, if let us say an image processing application, look at one research problem which I recently came to know when I was discussing with the IIT Mumbai PhD student is, now if you can have an image processing surveillance system which can actually take a video and photographs of leaves, okay, and that leaf, how the leaves are getting, how a plant is getting different type of diseases and all, and what kind of pesticides if you are using and to what extent these are going. If let us say an agriculture university has to do a survey on it, okay, how about let's say an unmanned aid vehicle like a small UAV aircraft kind of thing which is having a camera and goes through the complete state every month and does a survey report. See now, what is the technology which is behind that? An image processing, aerodynamics. Aerodynamics is a different subject, that you leave it. Okay. Now look at the necessity of that particular research problem in our society context. Unlike in UK or Canada or US, where farmers here are not having education. Farmers do not know how to tell the problems also what they are facing. So it has to be a different approach in solving their problems. If it is a different state, that farmer will drive in a car and come to an agricultural university, sit across the professor, speak professionally and solve the problem and get the solution. Okay, that is not the case. So I am trying to say that there are a lot of problems which especially our Indian society can be actually getting benefited, solutions can be benefited, and machine learning, whatever the machine learning algorithms which were developed in the last 2 decades, opens lot of new research fields. You can take up image processing, machine learning, signal processing, machine learning, communication system, machine learning, okay, embedded system, machine learning, robotics, machine learning, lot of new opportunities. Ultimately, the machine learning is trying to say that your machine can actually do some intelligence on top of simply saying, okay, when the LED says, when the LDR output is 1, you open a relay. When the LDR output is, that is what the machine so far it's been doing till today. But a machine can actually do a lot of analysis on its own and gives end report. Okay, I have done today's survey with let's say some 10,000 acres. Okay, already it has done actually research. The machine learning algorithm itself has processed, let us say, 1 lakh images. Okay, maybe a video which is actually long over 10 hours and gives you very final information. These are the leaves which are being affected by different diseases. These are the different kind of crops being seen from the maybe 20 meters height, which is a UAV. Now that is given to basically agricultural scientist, okay, somebody. Now see, that's what actually machine learning can do. Machine learning in the first initial days, it can do a lot of filtering of the data. Okay, now you may not be getting biased to only farmers. There are a lot of other problems are there. Banks, finance sector. Okay, now you may feel in the first grade machine learning is a computer science subject. Not so. What you understand is, when you have to implement lot of things in machine learning, you have to come back to again VLSI. You have to again come back to FPGA platform. And machine learning, when you are applying to signal processing, machine learning algorithm is a standard. which you may not be claiming any novelty, but applying that machine learning algorithm on a signal processing problem is a novelty. Okay, I am about to talk about those slides where how to climb innovation also easily. I will talk about that. It's not that identifying the shortcut, it is that doing some valuable output which is useful to an engineering or a society at the same time without breaking your head in fundamental research. Okay, yeah, that's what I am trying to emphasize. Academic research is very important. Okay, and I feel the new government which has come is appreciating the importance of that, and a lot of motivation is also there from government side in terms of encouraging new companies, in terms of encouraging funding to the training institutes and all. So young researchers can combine their PhD problem with a grant project. It's really a promising opportunity. You people need not think that I am in a college where actually there are not facilities and all. Unlike other departments, electronics and communication has got plenty of advantages. Computer science engineering, electronics communication engineering, even if you are in a right across a corner in a village where you just need to have a 230 volts power supply and a broadband connectivity. That's it. The entire world is with you. Stanford is with you, Oxford is with you, everything is with you. This opportunity is not there for other engineering disciplines. Maybe let us say chemical engineering. Even though you do a lot of things, paper calculations, you have to really put chemicals to do something and to really prove that. But in electronics communication, because this discipline is very much close to computer and all, you have plenty of simulation tools, plenty of open source tools. You really need not invest even 1 rupee also on buying a hardware. But still you can actually attack solving state-of-the-art technology problem. Maybe across the world only Stanford is working, Berkeley is working. You can also work on it without investing a single rupee on the hardware. Okay, so that's why, and there is a promising opportunity. I am seeing actually, I will show you, you can always browse on the web. I have got a couple of reports with me where I can show you maybe in some point of time in presentation. You can just see that if you ask a grant of 3 lakhs or 4 lakhs, all these government bodies, without seriously scrutinizing a proposal, they will sanction. Okay? If you are asking about a funding of somewhere around 10 lakhs or 20 lakhs, then yes, your problem need to have a sound, in terms of architecting or articulating your whatever the problem you are trying to say. And main thing is that it should address society problem. All these funding agencies look at how close you are trying to address a society engineering or a problem. Okay? That is also not tough to write. Okay? Then research may not be far from subjects being practiced while teaching to students. Most important. The reason why UTS is and String Technologies is trying to offer free training to the academicians is indirectly, if you become skilled, you become more knowledgeable. Through you, another 50 every year, another 100 every year should become conceptual. The very important purpose why all the academic institutes, right from small college to basically top universities like IITs, why they encourage all academicians to pursue research is, when you are doing research in a field, let us say VLSI, you will be knowing all the concepts and principles in VLSI thoroughly. And when you have to teach to your students also, you will be teaching in a best way, ultimate way. See, you know that there are teaching methodologies. Okay, I can also tell you how a bridge rectifier works. Okay, that all of you will students get 90% marks and no person will be able to design a single rectifier also. Or I can also train the people in such a way that people get only 50 marks. Okay, but then all of them are experts in designing this one. A teaching methodology can do a lot of variation. You can also train the people how to get good marks in exam, at the same time they get full practical exposure. Okay, and we do encourage the academicians to go beyond your lab exercises. See, because rules and anything which one has to frame, they have to frame keeping the worst things into consideration. See, 35 marks out of 100, that's what the pass today, I think in BTech colleges now, is coined to keeping some very low IQ people in consideration. And lab experiments 10 only coined considering that at least all the people should be able to complete these 10 experiments. You don't have to stop only with that. All of you, the intention of why academicians pursue research is, you are required to break your research problem, give it to your students, see that the intelligent students become actually take beyond their lab exercises solving some real-time problems. Average students go a little bit beyond their syllabus and work. Got it? And below average students, through your conceptual learning and all, in the subsequent days of their education, they are supposed to become average and above average. Got it? That is the reason, that is the bottom line why academicians should do research. Actual reason for that. Okay? May not be, your innovations may not be helping society, but your innovation, in the process of innovating research, you will learn all the things conceptually. Do you or not? See, whatever you do as a research topic, if you have to explain the principles in same subject, you will explain more conceptual, isn't it? That is the most important purpose. So do not choose a subject which is beyond your, which is not connected to your subjects or in other way. If you are pursuing a research topic, you speak to your HOD or a principal, tell them that I will be able to judgment to this particular topic and this particular subject, whatever way it is possible. Students can be partners in your initial days. At least, I mean, some of the students. Why in initial days? See, when you have to do literature survey, you have to stretch,